Alright, in this video we're going to talk about the contrapositive proof, which, if you know logic, is very intuitive. We have a statement, if psi then phi, or if phi then psi, sorry. We assume that the consequent is false, and we show that the antecedent is false. You should remember that phi arrow psi is directly equivalent to not psi arrow not phi, and that is all we're doing. We're simply reversing the order of the statements and negating them to an alternate method of proof. So, if 7x plus 9 is even, then x is odd. Well, how do we write that 7x plus 9 is even? We say, okay, 7x plus 9 is equal to some number 2k, and then we have to say x is odd, so we have to solve for x and figure out, well, that is just ridiculously hard. So, we can make this so much easier. Why don't we say, okay, if not x is odd, then not 7x plus 9 is even. Okay, and we know this is the same thing as saying if x is even, then 7x plus 9 is odd. Okay, well, I could do a proof here, a nice mathematical proof, but it should be obvious that if x is even, then 7 times x is even, and then an even plus an odd is going to be an odd, so we've just proven that 7x plus 9 is odd. So I'm being a little bit lazy with my proof there, but it's more to show that, hey, look, this proves the exact same statement. I'm saying, okay, let 7x plus 9 be phi, and let x is odd be psi. Okay, now I'm going to prove not psi, arrow not phi. So what you do is you assume not psi, which is what I did here, and then we prove not phi, which is what I did there. So, really not too bad. In fact, a little bit easier than doing it in a direct proof. Now, I have this blank page for one reason, and one reason only. So, if phi or psi, then chi. Suppose I want to do a contrapositive proof on this. Then I have if not chi, then not phi or psi, which happens to be if not chi, then not phi and not psi by De Morgan's law. So a common error here is that you just prove one of these and you say it's conclusive. Really, it's not. You have to check that both of those are negations. And of course, this is a logic thing, but in proofs, it is still very important that you have your logic correct. That's why we did logic first. So, this wasn't exactly too bad. However, consider the case where I say, if phi, then not chi and psi. Or rather, I'll just say if phi, then chi and psi. Okay, so if we assume phi, then we should be able to get both of these. However, if we have a contrapositive proof, what's interesting now is we get this nice logical equivalence. And when you have an or statement, this becomes a proof by case. So you have to be very careful when picking your proof method that you make sure the logic works, because here we have to have a proof 1 that starts with not chi and gets to not phi, and then you have to have another proof that starts with not psi and gets to not phi, and only then can you conclude not phi. So, be very careful with your logic. I know this is another fast video, but the point is to show proof methods, not proof examples. I do give you one example in each proof method, but this one is special in that the logic is very, very important to take care of. In fact, that's why most of this video is based on the logic as opposed to the actual proof method. So as an example, and I will give an example of this here. Let's say if, in fact, this isn't exactly a nice mathematical proof. This is sort of an everyday, you know, kind of fun proof. If it rains, then you are wet, or you are inside. Okay, well, it's kind of hard to say, well, if it rains, I'm wet or I'm inside. So let's prove the contrapositive. So what we do is we negate this statement, we negate the first statement. Whoa, I did not know I could do that. That is very cool. If it rains, then you are wet or you are inside. So what this will say is that if not wet and not inside, then it is not raining. Well, this is a little bit easier to observe, since if you say, hey look, there's a dude outside who's dry, then you can pretty much conclude it's not raining. So maybe a little bit easier to do with the contrapositive, but you have to remember, as always, to properly negate your signs and your operators, otherwise you have a little bit of an issue. So that was proof by contraposition, contrapositive proof, contrapalooza, as some hippie mathematicians might say. No, that was a terrible joke, I'm sorry. Anyways, if you have any questions, leave them in the comments. I will get to them as soon as possible.